We've now looked at basic trig functions and their properties, such as domain, range, their inverses, etc. But now we're going to look more closely at how these trig functions relate to each other and how to solve and simplify other trig relationships. To start with this process, we're going to review some of the trig identities that we've already looked at. And remember, identities are things that are always true. For example, the additive identity 5 plus 0 equals 5, that's always true. This is compared to something that's conditional, such as an equation 3x minus 5 equals 12. It's conditional on x being a certain value. These are just review. Remember, we've already looked at reciprocal identities. These are definitions. You know that 1 over the sine is always the cosecant, 1 over the tangent is always the cotangent, and then our quotient identities, tangent is sine over cosine, and so forth. These are your co-function identities. Again, we've already seen these. Some common ones that are going to pop up throughout the next couple of sections. And then our period identities. And again, don't try to necessarily memorize these, but just picture how often the cosine repeats, how periodic it is, how often tangent repeats, and that's going to help you remember these particular values. We've also looked at the even and odd identities. Remember, these functions are odd, meaning that when you plug in negative x, you get the negative of the function. And here, these are even functions, meaning when you plug in a negative x, you just get cosine of x. These last three identities we haven't really seen, but we can see how to derive them. If you remember from our unit circle, we know that the xy value is cosine sine. So if we pull that out as a triangle, we know that the x value is cosine, the y value is sine, and then this is our hypotenuse of 1 since it's a unit circle. That goes straight to, using the Pythagorean theorem, sine squared of x plus cosine squared of x equals 1. And then if we want to rearrange those, we can consider sine squared of x plus cosine squared of x equals 1 if we divide everything by cosine squared. Notice this becomes tangent squared, this becomes 1, and this becomes secant squared. And likewise, this can be found by taking the original identity and dividing it by sine squared. So how might we use these? Well, first off here, one of the recommendations I make is always try to get things in terms of sines and cosines. So for example, if we have the cosine of theta plus sine of theta tan of theta, and we just want to simplify that, if we rewrite tangent of theta in that relationship of sine and cosine, notice then this becomes cosine of theta plus sine squared over cosine theta. And then finding a common denominator, this becomes cosine squared of theta plus sine squared theta over cosine theta. And remember, this is one of our identities from the Pythagorean identities. So this becomes 1 over the cosine of theta or the secant of theta, which is much simpler than that original relationship we had. Another example, if we look here at the cotangent of alpha plus sine of alpha over 1 plus cosine of alpha. Again, getting things in terms of sine and cosine can simplify things. So this becomes cosine of alpha over sine of alpha plus sine of alpha plus 1 over cosine of alpha. Again, our common denominator here is going to be that 1 plus cosine of alpha. So that gives us cosine of alpha times 1 plus cosine of alpha, plus we need to multiply here by the sine of alpha, so that this denominator becomes part of this over here. And that leaves us with sine of alpha times 1 plus cosine of alpha. When we distribute and simplify, we get cosine of alpha plus cosine squared of alpha plus sine squared of alpha all over the sine of alpha plus cosine. Sorry, we're going to leave it not multiplied out, plus the cosine of alpha. Up top, that leaves us with the cosine of alpha plus 1. Remember, this part is plus 1, all over the sine of alpha times 1 plus cosine of alpha, which lets these cancel, and we end up with 1 over the sine of alpha or the cosecant of alpha.